Okay, the Chamber of Commerce of a Florida Gulf Coast community advertises that area residential property is available at a mean cost of $125,000 or less per lot. Suppose a sample of 32 properties provided a sample mean of $130,000 per lot and a sample standard deviation of 12,500. Use a .05 level of significance to test the validity of the advertising claim. Okay, we have a hypothesis test problem here. And again, we'll consider it a 5-step procedure. We want to set up the null and alternative hypotheses. Now, the Florida Gulf Coast community has made a claim that the properties are no more than $125,000 on average. However, we have a sample here where the sample provided a mean of 130,000. So seems like there might be a little evidence contrary to the claim, and we want to test it. What we'll assume, though, is that the average is less than or equal to the $125,000 as claimed by the community. And the alternative is basically the opposite to that. And we want to run the test to see if that $130,000 sample average is enough evidence to reject the null and show that the actual average of the properties is greater than what is claimed. So we'll see if that's true. Now, 130,000 is from a sample, by the way, so it's just a sample. It doesn't necessarily prove conclusively that the overall population average is greater than the 125,000. It'll all depend upon the variation, standard error, and the other issues of sample size and everything else sort of plays into that to see if the evidence ultimately that we have is strong enough to go and reject that null. The second step of the hypothesis test is to look at the sampling distribution. We'll have, in this case, a t-distribution. We'll be using a t-distribution because our sample size is 32, but the standard deviation is taken from that sample as opposed to having sigma, the population standard deviation. Now, the center of the distribution is the $125,000 claimed average. We have a level of significance of 5%. We're testing on the upper end in this case. This is a one-tailed hypothesis test. And we have a standard error. We'll go ahead and calculate that. That's the sample standard deviation divided by the square root of the sample size, 32. So if I go ahead and calculate that out, I get 2,209.71. Now, again, this is a t-distribution because I'm working with the sample standard deviation. And although 32 in some arenas is considered large, a lot of times to be safe, we use a t-distribution because that standard deviation is coming strictly from the sample. As I mentioned in the content portion of this module, planning values or estimates of sigma that use a lot more data or experience to create that they're more reliable, we could go ahead and have used the z-table. But in this case, the standard deviation is only coming from one single sample. And because that sample, in some sense, is small when it comes to producing maybe a very good estimate of sigma, then we're going to go ahead and use the t-distribution here. Now, in using the t-distribution, I have a sample size of 32, so I want to define my degrees of freedom. This is pretty much the same as it always was. It's n minus 1, and 32 minus 1 is 31. So I'm going to be looking in row 31 on my t-distribution table. And by the way, that can be found in Appendix B, page 920 in your textbook. The column, the upper tail area, is 0.05. So my t-value, my critical value for my test here, is 1.696. So 1.696. Now, I can create my rejection rule. I'm going to reject h sub 0 if my test statistic, which I'll calculate in a moment, is greater than or equal to the 1.696 critical value. My test statistic, of course, is the basically the t-score or t-value for my $130,000 sample average. So I'll take that and subtract the claimed amount that I'm testing against here and divide by the standard deviation of the sampling distribution, or the standard error, and I get a value of 2.26. So comparing that to the critical value of 1.696, 2.26 is greater than 1.696. So reject h sub 0. So I have enough evidence to prove. I can take an action now. I've proven something, that the average cost of the properties is greater than the claimed amount of $125,000. I have statistical proof that that is true. So I'm rejecting the null hypothesis, and I'm proving the alternative, therefore. Again, a hypothesis test using the t-table is pretty much the same as using the z-table. It's just that in this situation I'm dealing with a standard deviation that's coming from one single sample. So I'm going to use a t-distribution for that. Now, what if we want to run this test using a p-value? We would set up the same null and alternative hypotheses, and we would come up with the same test statistic for our sample average. By the way, the 130,000 we knew was to the right of our critical value line, because our test statistic was greater than our critical value. And so we were far enough away from the 125,000 to go ahead and reject the null hypothesis. What is the p-value? How would I calculate the p-value here? We're actually further to the right than we had to be get the rejection, and the p-value is going to give us a feeling of just where our location is and give us even more confidence that the null is wrong. But what is that p-value? How do I calculate it? Now, with standard normal, it's a little bit different. You can go ahead and estimate it pretty closely in the table, but the t-distribution table doesn't have a lot of resolution to it, or as much resolution. So what I'm going to look at is the test statistic, and I'm going to go to the t-table. Looking at the row of my sample size 32, I find that my test statistic, and looking across that row, I find the number 2.037 and then 2.449, and I find that my test statistic is right between those two numbers. Now notice that the 2.037 is in column 0.025, and the 2.449 is in the column 0.01. So I know that the p-value with a test statistic 2.26 is somewhere between this 0.01 and 0.025. Now the way I would state that is 0.01 less than p less than 0.025. So I don't know exactly what my p-value is here, or not precisely what it is, but I know it's somewhere between 0.01 and 0.025. Now, if you're working in the online software, it may ask you to give an estimate of the p-value when you're using a t-distribution. And if it's a multiple choice, it may give you one of these as the choices, and you would click this as the answer. The p-value is somewhere between 0.01 and 0.025. There are instructions on how to calculate a p-value using Excel and get it more accurately. And if you look at those instructions, you'll find that the p-value actually turns out to be more like 0.0154. 0.0154. And you can get that using Excel and following the instructions on the handout that was given. So with that 0.0154, I would reject h sub 0, since 0.0154 is less than 0.05. So originally I had 5% level of significance. I had allowable 5% error. But actually, the error involved is much smaller than that. It's more like 1.5%. So the chance of being wrong about this is even less than what I would have allowed, and therefore most certainly I'm going to reject the null hypothesis. The p-value is giving you maybe a better feeling for where your sample estimate is in relation to your hypothesized value. And this is further out, further away from that than it had to be to get the rejection. So even more so I'm going to reject. It's giving me a feeling for my confidence in rejecting, my confidence that I have not made a type 1 error.